on everybody, and welcome back to Jumanji. In the previous video, we did a quick run over on citrus essential oil. Now within that oil is this wonderful compound called limonene. Let's see how much chemistry we can squeeze out of it, right? Let's start by naming it. Your longest carbon chain will go to your cyclohexene ring, right? And your top priority #1 carbon will go to the carbon with your double bond. So 1, 2, 3, 4. On your #1 carbon, you have a methyl group, right? And on #4 carbon, you have a 1-methyl-ethenyl cyclohexene, right? Limonene is also a chiral enantiomer. It is an enantiomer because they are mirror images of each other, right? These are non-superimposable mirror images. It is a chiral molecule because no matter where you split the cyclic molecule in half, you'll have 2 different molecules on either side of your half. And your chiral center, your chiral carbon will be this one right here, right? This carbon is chiral because it is attached to 4 distinct functional groups. You have 1 group here, you have 1 group on this side, 1 on this side, and you have a hydrogen that we didn't write it because we know that neutral carbon has 4 bonds, right? When you have a molecule that's a chiral enantiomer, it's going to have an absolute configuration, right? That's its 3D absolute configuration. This absolute configuration will allow light to rotate in a clockwise or anti-clockwise direction around your chiral center, right? So you're going to have an absolute configuration and you have a relative configuration. When your absolute configuration allows light to rotate in a clockwise direction, it gets an R, right? And when light rotates in a clockwise direction, or your right, dexter, it gets a D or a positive sign. When your absolute configuration allows light to be rotated in the anti-clockwise direction, or your left, your absolute configuration gets an S, right? Your relative configuration gets an L for lavus or left, noted by your negative sign here.